Student friends, once again we are continuing with radio receiver and television communication. In the last week, in the last period, we covered horizontal sync pulse and its blanking standard in composite video signal. But friends, composite video signal is nothing but the combination of video signal proportional to the picture information snapped by the camera, horizontal sync and horizontal blanking pulses, along with the vertical sync pulse and vertical blanking pulses. Out of these three, we studied two. One is video signal proportional to the picture information. Another one is horizontal blanking standards. Friends, today we are going to continue with vertical sync pulse and its blanking standards. As like horizontal sync pulse and its blanking standards, which are introduced at the end of every horizontal trace period or at the beginning of every retrace period to blank the screen and also to synchronize the horizontal and vertical coordinates which are scanned in the camera. Analogous to that, when one vertical frame completes, means when 625 horizontal lines are scanned, or if it is interlaced scanning, in every 312 and half lines are being scanned. After that scan, vertical sync and blanking pulses are introduced. In short, vertical pulse and blanking pulses are introduced at the end of every field, that is at the end of odd field where the odd field retrace begins, or at the end, and also at the end of even field where even vertical retrace begins. These pulses are known as vertical sync pulse and also the blanking pulses. They have their own standards. Those standards we are going to study. Their role is to blank the screen during the vertical retrace period and also to synchronize the vertical scanning which are being scanned in the camera, same as to be scanned on the television screen. Friends, these pulses are introduced at the end of each field scanning 312 and half lines. Meaning thereby, at the end of every field, at the end of odd field, also at the end of even field, both are to be interlaced with each other, and that particular respective vertical retrace periods, these pulses are introduced. Friends, these are being represented in this particular picture representation or graphical representation. Dear students, there are two sets of these particular pulses which have the same pulses but introduced. One set at the end of odd field, another set at the end of the even field. So that's why they are represented in the two types. Friends, let us look to this particular bottom diagram which you already studied. Or this is same as that of this particular diagram, these particular pulses. So almost all the pulses are same, but those are to be introduced. One set of pulses introduced at the end of odd field, another set of pulses introduced at the end of even field. That is the difference. Otherwise, each and every aspect of the set of pulses have got the same meaning. They are going to do the same function in the respective retrace period of the respective fields. Dear friends, we are aware that as far as horizontal blanking standards are considered, so this is the horizontal blanking period, front porch, sync pulse and back porch, and this is what it is represented. It is called as the picture information. So after picture information ends, means at the end of 312 and a half lines, the vertical sync pulse and blanking pulses are introduced. Means these are the set of pulses. Look at here. These set of pulses, we can call it as the vertical sync pulses and the blanking pulses. So these we have studied in the horizontal blanking standards. This as well as this part we have studied. Again I will repeat, this is the horizontal blanking pulse containing front porch, sync pulse and also the blanking pulse, whereas this part it is called as the video signal proportional to the picture information. This also represents the same. Here odd field completes. Means we know that when we have studied the interlace scanning, at the end of odd field, the bright spot reaches to the center of the bottom of the television screen, and when the spot reaches to the center of the bottom of the screen, this set of pulses are applied to the vertical deflection system. These are called as vertical sync pulse and the blanking pulses. This consists of equalizing pulses. These are called as pre-equalizing pulses. Then this is the serrated pulses or vertical sync pulses, and then these are called as post-equalizing pulses. After that, again next field starts scanning like this particular way, and when 625th line is scanned and spot reaches to the right of the bottom of the screen, again same set of pulses are introduced that also carrying pre-equalizing pulses, vertical sync pulses and post-equalizing pulses. The role of pre-equalizing pulses is to isolate the horizontal scanning and vertical retrace period from each other. And also the role of post-equalizing pulses is to isolate beginning of next field, that is horizontal scanning, and also the end of vertical retrace period from each other. In between that, there are the serrated pulses, there are the vertical sync pulses, which does the job of vertical synchronization of the camera scan and also the television screen scan, and also to interlace odd field as well as even field with each other. If suppose there is a color information is there, color transmission is there, in addition to respective these sync pulses, here especially arrow is represented, front porch, then this is sync pulse. So in the back porch there are color burst signals are applied in the horizontal sync pulse in the back porch especially. So those are called as 8 cycles of color subcarrier frequency known as color burst signal. So this is the identification of the chrominance transmission as well as the monochrome transmission. If this chrominance burst signal is present in the composite video signal, then we can say it is color composite video signal, which is going to differentiate between monochromatic transmission as well as the chromatic transmission. In absence of these pulses indicates that there is a monochrome transmission. Presence of subcarrier frequency or color burst of 5 to 8 cycles approximately with the frequency of 4.8 megahertz represents the color transmission. As we already studied that the horizontal blanking pulses, vertical blanking pulses are monitored at every transmission center to recognize the quality of the picture which is being transmitted. If the standards are maintained, as we are aware that front porch is of 4.8 microsecond, sync pulse is 1.5 microsecond, and back porch is of 5.7 microsecond, Totally it is a 12 microsecond, 52 microseconds carries the video signal. If all these standards are amplitude levels are also fixed, which is going to vary between 75% to 100%. If all these standards are maintained by the horizontal blanking standards, then we can say the transmission is totally clear. Analogous to that, there are the standards for pre-equalizing pulses, serrated pulses, that is synchronizing pulses, and also the post-equalizing pulses for both these sets. Those standards are also essentially monitored, and depending upon that, the quality of the picture information to be transmitted is going to be decided. Let us see what are those respective standards. Friends, as it contains the field blanking pulses, means these are called as serrated pulses, these are vertical sync pulses. It is a longer duration to distinguish between line and vertical sync pulse. To avoid the interruption of the line sync in a field sync, it is split by serration each of 4.7 microsecond wide into 5 half-line rhythm narrow pulses of 27.3 microsecond wide. The half-line rhythm is necessary because it occurs at the middle of 312 and half line of odd and 625th line of the even field. Means these field blanking pulses have got their standards of 4.7 microsecond wide, separated by 27.3 microsecond wide, which are introduced in the middle of 312 and half lines of odd field and 625th of line of even field. Friends, this entire set we can call it as the field blanking pulses. So these are the serrated pulses. This width is of 27.3 microsecond, whereas this one is 4.7 microsecond. Furthermore, pre-equalizing pulses, the receiver deflection circuit have to separate vertical sync pulse from the line pulse to produce the composite video signal pulse to trigger and synchronize the vertical oscillator. For particular perfect interlace pulse produced in exactly similar condition on both odd and even fields. These are of the 5 half line period, each of 2.3 microsecond wide. Means these pulses. Okay, 1, 2, 3, 4, 5 pulses are introduced. These are called as pre-equalizing pulses, having 2.3 microsecond wide. Next, post-equalizing pulses. Following the last 5 vertical sync pulses, there is a half line period of odd field and full line period of next even field. It is necessary to introduce 5 equalizing pulses at the end of field sync pulses also that maintain line sync pulse without gap. These are of 2.3 microsecond wide. Means so these pulses, which are called as post-equalizing pulses, they are also the half the line period with the width is 2.3 microsecond. So these are the standards which are associated for the vertical sync and their respective blanking pulses. Their role is to synchronize the vertical scanning and also to keep the screen blank during the vertical retrace period and to interlace two field with each other. So that is being done by means of an vertical sync pulses and also the respective blanking pulses. So that's all about vertical sync pulse and also the blanking standards. Let us proceed further to study one of the repetitive aspect which I already studied in topic number 2, that is vestigial sideband. When we studied the modulation and demodulation topic, we have introduced the meaning of vestigial sideband. Friends, we are already aware that during the transmission purpose, to save the power, carrier wave is suppressed and DSB or SSB is used to carry the information from transmitter towards the receiver. But especially in television communication, SSB is also avoided, and in place of that, VSB is adopted. VSB means vestigial sideband. This is adapted only to reduce the bandwidth for the television communication. Friends, as we are aware that television signal contains the audio signal as well as video signal, along with sync and blanking pulses, which are expected to be communicated from transmitter to the receiver within the same bandwidth. And if DSB is used, 10 MHz bandwidth is required for the communication. If SSB is used, some DC level frequencies that containing the picture information may going to wash out. And that's why in vestigial sideband, upper sideband is completely transmitted, which is of the 5 MHz. And to get the DC level picture frequencies, some part of the lower sideband is considered. That some part of the lower sideband, we can call it as it is a vestige of the band. And that's why the name is given as a vestigial sideband, abbreviated as a VSB. Hence, the bandwidth becomes 7 MHz instead of 10 MHz. 3 MHz bandwidth is saved. And within 7 MHz bandwidth, almost all audio, video signal, sync pulses, blanking pulses, all those are going to be gets transmitted. Friends, during this particular aspect, entire 5 MHz upper band is transmitted, but at 5.5 MHz, sound carrier is introduced, and the lower sideband is considered from 1.25 MHz frequency. So that is 5.5 MHz plus 1.25 MHz. 6.75 MHz that becomes, and 0.25 MHz is guard band. Hence the net bandwidth becomes 7 MHz instead of 10 MHz, which is sufficient to transmit the entire television signal from transmitter towards the receiver. This is what we can call it as the concept of vestigial sideband. Friends, already we have introduced in the topic number 2. It is a merely repetition, but we are going to consider the same as a part of your syllabus. Let us see line by line. In television picture, bandwidth is 5 MHz. Okay, upper sideband is 5 MHz and lower sideband is 5 MHz. Total is 10 MHz. That means DSB bandwidth is 10 MHz. SSB bandwidth is 5 MHz. If transmission is done by normal broadcasting, 10 MHz bandwidth is required. Means if DSB is used to transmit. To reduce bandwidth under normal broadcasting, one sideband is completely transmitted. Upper sideband is completely transmitted. And for other sideband, some part is called as a vestige is used for transmission to get the 7 MHz bandwidth. And this is what you can call it as VSB, that is vestigial sideband. What exactly it is done? From bandwidth diagram, we can say whole upper sideband is transmitted to get the bandwidth of 5 MHz, but for lower sideband, as television signal contains the DC level signal frequency, instead of suppressing completely, part is suppressed and remaining part known as a vestige of sideband is transmitted. What standards which are being used? Thus VSB 0 to 0.7 MHz signal is present from the lower sideband, that is lower as well as upper sideband. While above 0.75 MHz up to 5 MHz signals are only present from the upper sideband, which are not taken from the lower sideband. Hence, upper sideband is fully transmitted and lower sideband is passed only from 0.75 MHz. That is, lower sideband is suppressed at 1.25 MHz or upper sideband is attenuated at 5.5 MHz, where the sound carrier is introduced. 5.5 plus 1.25. The sound carrier with the deviation of plus or minus 50 kHz is inserted at 5.5 MHz. Thus, it allows bandwidth of 7 MHz from 1.25 MHz to 5.75 MHz with 0.25 MHz as a guard band. So 1.25 plus 5.5 becomes 5.75, sorry, 5.75 plus 1.25, that becomes 7 MHz. Within that 7 MHz, 0.25 MHz is guard band. Same it is going to be represented in this particular diagram. This diagram already was studied, friends. So we are aware that this is the carrier that represents which is expected to be suppressed. This is the upper sideband. This one is the lower sideband. Upper sideband is from 0 to 5 MHz up to here. Lower sideband is also from 0 to 5 MHz. But if you transmit this 5 to this 5 MHz DSB, it becomes 10 MHz bandwidth. If it is not necessary, if you transmit only one of the 5 MHz band, there may be possibility of washing out the DC level frequency. To consider those DC level frequencies, what done is the upper sideband is considered fully up to 5 MHz, whereas lower sideband is clipped at 1.25 MHz here. So from 125 MHz up to 5 MHz, 5 plus 1.25, 6.25, we got it. Now at 5.5 MHz, sound carrier is introduced. Look it here. Here, this is what it is called as sound carrier. So it is 5.5 MHz and 1.25 MHz. 5.5, 6.5, 6.75 plus this is the guard band of 0.25 MHz. So net becomes from this to this, it is a 7 MHz. Look it here. From this to this 5 MHz, from this to this 1.25 MHz, and this is of 0.25 MHz. 0.25 MHz plus 5.5 MHz plus 1.25 MHz. Total becomes 7 MHz. So this is called as the vestigial sideband. From this to this, it is called as vestige. Some part of the lower sideband it is considered. And this is totally removed. Shaded area is totally not transmitted. So this is the space we can save. We can save 4.25 MHz bandwidth. So that is what the concept of vestigial sideband used in television transmission to transmit the television signal. Maybe it is a chromatic or maybe it is the monochromatic signal. Friends, that's all about the meaning of vertical sync pulse and blanking standard along with the concept of vestigial sideband. Next time we will go for the next aspect of television communication.